this was actually scheduled more as a time for Leif and I to do some hacking on, get some ideas on what we wanted to do with this. So the slide that's up is the only slide we have. There is an Etherpad, which I have managed to rope Steve into updating, if we actually get new stuff to go into it. And all I can really do at this point is kick off from where we were with the last meeting and give you some idea of what I can actually give for in the refactoring. So if we start off with that, what Lava is hoping to be able to provide. We know the problems at the moment that you can't sensibly test outside of a POSIX shell. It's basically the limitation of the current dispatcher. Everything tries to put some kind of POSIX shell on it. Even when we're doing ADB tests, you end up putting BusyBox on the thing to actually have some kind of shell. Right. So that's all gone away. We are putting in a new design that allows us to say, right, we can have a protocol. It's not a shell. It's not a standard way of interpreting something. It's a limited environment. It responds to only certain commands. We set those commands in the Python code. We understand what API we're talking on, and then we can actually run that as a test. So we'll get you into an environment, and we'll get you into a test that is not a test shell. At that point, the compatibility that we are keeping with Lava test shell definition becomes unnecessary, because there's no way of this being compatible anyway. So we've got a free hand. We can keep the basic structure of the test definition, whatever is relevant to what we actually need for these kinds of jobs. But the idea of Lava test case -- shell is redundant, can't really do it. So there'll be new ways of effectively having something executed on the far end, and some way of that thing telling us whether that was a pass or a fail, or whether it was a measurement and what comes back from that. So there'll be ways of doing that as yet undefined, but they'll have to be defined by the protocol itself, because they are dependent on what is on the far end. So each of these will be specially developed. They're one-off for that particular thing, and they'll need to migrate if that thing updates. So that will all be built in. It'll be a case of you've now got a whole new environment, and you've got the new support that is custom for that particular thing that you're connecting to. That is basically, that has been scoped in the last 5 minutes. So that's how new it is. But we have the infrastructure already in place to support everything that I've actually thought through. It's just the implementation is going to need to be custom for each one. So it takes a concerted effort by someone who knows the far end well to write exactly, to explain to us what the API actually is, exactly how you want to get stuff out of it.
Yeah, I mean, that's really useful for us, because the reality we have is we're hoping to be working with many different platforms that will have many different user interfaces which you'll need to run in different ways, at which point the old Lava design was just not workable. No. The best thing you could hope for was to be able to set everything up automated such that it would at some point drop into a shell and Lava would go, oh, look, that's a shell. So yeah, having that ability is going to be important.
The useful thing we've already got in the design as well is that you don't need to try and get anything off the system to get results. The results are in our interaction over this protocol, and we define exactly how that's done, what the meaning is, but those are then logged live. So there's no thinking about, oh, this particular bootloader or this particular environment now needs to write to media so that we can look at this after it's booted into an image. You can put that support in if it's relevant, but it's not necessary, it's not mandatory. And equally, you don't have to boot an image at all if your particular test of this thing doesn't require booting something that looks like an image. hard part is making sure that you have ways of resetting the device for the next job. Now, on a lot of these devices, you're going to be limited as to whether you can put a custom build of this thing that far down the stack. That's going to be a difficult thing to do because it depends very much on exactly what the device can do as to whether the device allows us to recover from a broken UEFI or something that's put on there that just can't boot.
Yeah, but I mean, again, that also will vary from platform to platform, and for some of them, you can probably just hide it in the protocol. For some of them, we will probably want to explicitly be running UEFI implementations that we never change, that are just part of the hardware, at which point either we have ways of forcing a reset, or we have a PDU, and try to work it that way. And if that turns out to be insufficient, then we probably end up not being able to run automated tests on those platforms. But that would really be a serious failure case. Yeah. But also on the for leg, it's going to be a bit easier than possibly for others, because I expect most of the platforms we have, they will have, well, not IPMI these days. I guess it's called Redfish now. But something which either you can drive via a standardized protocol, or to have some kind of board control module which lets you just telnet in, connect, send, throw XML at it, and just get it to reset. And so that it's probably going to be easier for leg once we have more real hardware to work on than it's going to be for most other teams to get this working, because the server use case kind of requires you to have this ability. Yeah. Whereas for most other platforms, it's a useful feature to have.
Which means that a lot of them just don't implement it at all.
And some of those who do, it will be broken on.
Yeah, because they've never tested it.
Yeah.
Yeah. So, which one?
Sorry, is this, are you guys talking about luvOS yet, or just UEFI?
Both. Well, what we said at the start was that this was arranged to be a hacking session between myself and Leif. And the fact that there are other people in the room is incidental. So.
I think luvOS, and so my understanding of the images that I've seen is that we bootstrap it with a model, and it boots up, boots a kernel, and then tests run, and then it's run level 5, which is false, right? And then it puts the results somewhere, and then they have to be extracted later on. My question is, does anybody know how Intel is automating this? That seems like that's somebody's doing that at their desk and then pulling the USB stick out and plugging it in their computer, looking at the results. It doesn't seem like that can be automated in any way, so I'm just curious if you guys know how this works.
Automating which piece?
But how they're automating the luvOS testing at Intel? Because it looks like, to me, it looks like, okay, so you've got to have some sort of something to scrape all the output that comes off there, or access the media, but you don't have any console. So I'm curious how they're working around that, or does anybody know how they're automating the luvOS testing at Intel? That's my question. Or is it being done manually, and we're trying to automate something that's being done manually at Intel?
Why don't you need console?
What's that?
Why don't you need console?
Because it just stops. That's the way it's designed. It's run level 5. It's like you're stopping around anything else. It halts the system, essentially. Which kind of seems like the wrong thing to do. And that's what I'm getting at, is that do we need to be sending patches to luvOS to say, this doesn't really make sense. We have this use case where we want to interact with the console. Perhaps don't run the tests until we actually boot into this image, and then we can manually invoke the test. Because I could imagine that somebody wants to run a single test case at some point.
But if we have a protocol that understands the far end, then we might be able to run the test without booting into anything else at all. That's what we're trying to pin down. And then whatever you've got at the far end, as long as we understand in the Python code that implements the protocol, as long as we understand what you can do at the far end, what's safe to do, what's not safe to do, then the whole idea of needing any kind of shell goes out the window. You don't have to boot anything at all.
This doesn't seem like it was ever designed to be automated in that sense.
No. So one thing you need to realize about luvOS is that you're talking about wanting to run individual tests. That's probably true, but that's not part of luvOS. luvOS is kind of this thing, which is, here's my one CD, I stick it in my machine, I run it, and I see whether or not there are any obvious bugs in the firmware implementation. So running the entire suite and getting a yay or nay is kind of what it's designed to do.
To me, the thing I would look to do is, you know, a Pixie boot, UEFI. That's what I would look to do in the end, right? In addition to having local media. I haven't tried the network boot. I don't even know the network boot option works with luvOS. I've only seen the local media use case, but that would be the thing I would do, and then I would have it reboot recently at the end, so that I don't time out the setting.
Yeah, that's kind of what I'm getting at, is that it doesn't, so assuming that all the results come out standard out, is that a reasonable assumption?
Not necessarily. The protocol can actually work out where those results are going to come from. There may well be a second cable or a management interface or some other.
That's what I'm getting at. Okay, so not all the results are displayed standard out. You can't parse them in your method that you're explaining. So how do you get
No, but
the results that were written to the file system back into the automation framework? That's what I don't understand. I'm trying to get my head around.
Well, I mean, that's the kind of thing which, so I really want to drop the focus on the console. So having this protocol thing just allows me to abstract that out and do whatever is sensible. But the main point is that you're actually running a Linux, right? So at the point when your tests have completed and not completely destroyed the system, you have a Linux in there which can just go and upload the files somewhere else. So, I mean, you don't need to try to parse that out of the console.
How would you, out of the console, how would you tell Linux to do that? With, you know, from an automation framework's point of view.
I mean, we just add something into luvOS to know how
That's
to.
what I'm getting at. I think that to do this, I think we need some tweaks that may need to go upstream to luvOS.
Oh yeah, quite likely, yeah.
Okay.
You want to be able to do a network boot, get the results, and then that's it, right?
Yeah. I just don't understand the reason why they didn't provide a console, because if we got the console, it would just be easy thing. I mean, do people not use this actively?
It's because this is kind of what we always get back to. We come from an embedded background. We expect a serial console. They come from a PC background. They expect an interactive, you know,
Something with a display.
keyboard display. Yeah.
Yeah.
That's where the big gap is.
Yeah.
Sorry for the tangent.
That's fine. We don't have much else to say.
No, this is it. It's a case of we've got the rough idea, we've got the bits in place to implement it. We need some dedicated hacking time to work out what the API of this protocol is for each particular device in each particular case. And then it's a case of writing the code and testing it. But the infrastructure to do it is in the refactoring. It is possible to do this.
Can I ask what the network boot situation stands right now? Like, can you do a network boot?
Yeah, that's been possible for quite a while. The only thing is that what we're lacking is real platforms. So yeah, we can network boot in QEMU or the foundation model or on Juno, which we do by loading the firmware on via the back door on a USB cable. And, you know, so yeah, the network boot isn't a problem, but we don't have any real platforms where you actually, a commercial BIOS type thing to run it on.
Do we need to work out how we get a Pixie boot in Lava?
Yeah. That's already theoretically scoped. Is Matt here? That's your job.
He was only playing with me.
He's just behind you, Dave.
Because we could drop that in our Red Hat automation framework. We would then drop that in our feature system.
So the current dispatcher has limited Pixie boot.
No Pixie. It's
TFTP.
There's a difference.
Right, okay.
So the issue there with Pixie is that when you guys think of Pixie image, you're like, there's one image that we want to Pixie boot. With Lava, it's like we need to be able to change it out. So the thought that I talked about earlier in the Lava users forum is we would have to, it's obviously
Well, that's all that Leif and I have got, so
Have back some of your day.